All right, this video might not make sense for you because it's part 2 of a nerve impulse video. So do me a favor, if you're kind of confused, go to part 1 first, then come back here to part 2. So right where we were just right here. We're zooming on the axon, right? So let's draw the axon. So what happened was, to create an impulse, sodium came rushing in, okay? So now I have sodium coming on the inside. So let's go ahead and, you know what, let's draw this really big. Why am I wasting my time? Let's draw it. Can I draw it way big for you guys? So now let's go ahead and draw it. If this is my nerve impulse, I have sodium who just came rushing in. So now I have Na plus in here. I have K plus here. I got to positive 30. I created a nerve impulse, zing, and everyone's chilling inside the nerve now. I think we like that. Okay, so now let's go to step 3, which is repolarization. Potassium gates open. K plus leaves. So now if you look, everything's backwards to where it was. Okay. In fact, let's draw resting down here. If I draw resting down here, because the nerve impulse hasn't gotten here yet, sodium outside, potassium inside. So if you guys look at these pictures, you can see how they're exact opposites of each other. And the whole point is so you guys can see here in the middle. If I'm a nerve impulse and I'm electricity, I can go either direction. The whole point of this is going to be what we call a refractory period. Since I pumped out the wrong one, which isn't an accident, I'm trying to make it sound like an accident, that means this nerve's temporarily going to shut down, which means a nerve impulse can never go backwards. That's why sensory go to the brain and motor go away from the brain. They are one-way streets. Well, if the nerve impulse can't go backwards, that must mean then it's going to go forward. So then it goes to this one where sodium can come rushing in, and then this one temporarily shuts down. By the time this one temporarily shuts down, I finally do the 4th stage over here, which is called recovery. And if you guys remember recovery, this is where I use infinite amounts of ATP to fix all this problem. So let's fix it. Whoop, whoop. Problem fixed. Okay. So now what we have over here is we have Na plus back where he belongs. We have K plus back inside where he belongs. My protein's in here. He never really leaves. And I can fire again. So if you guys want to do me a favor, every time you think of a sensory neuron, please think of it like this. Think of it as like a nerve impulse, space, nerve impulse, space, nerve impulse, space, nerve impulse, space, because it has a temporarily shut down. So it looks like a machine gun shooting bullets towards the brain, saying that's how many signals it can do. But you have to have that stage 4 recovery page in there, or that repolarization stage in there, so the nerve impulse travels a single direction. Now, I haven't officially shown you the wordy parts yet for stage 4. Stage 4, it's called recovery or refractory, where I use pumps. Anytime you see the word pumps, you better tie it to the magic word ATP. That is a must. And the whole point of this is so nerve impulses only go a single direction. Now, don't get me wrong. I think it's so much easier to teach like this. I think it's easier to teach stage 1, okay, resting, stage 2, action. And if you remember action, okay, that's where sodium comes rushing in, zoom, to get to positive 30. Down here, we started at negative 70 millivolts, okay? Then we go to stage 3. If you remember stage 3, my goal is I want to get back to negative 70, but the problem is I moved the wrong guy. Because K plus has been inside this whole time, and on stage 3, repolarization, K plus goes out and sodium's inside. So that's kind of messed up. So in stage 4, I have to fix this problem. So stage 4, I take all the K plus, try to pump him in. I take all the Na plus, try to pump him out, and I roughly stay at over here still negative 70. Okay? These are your 4 stages of a nerve impulse. But the whole point of this stage right here, which I can't stress enough, is the reason why these stages are so important is so the nerve impulse cannot go backwards. It can't. But it costs me infinite amounts, and by infinite I mean infinite amounts of ATP to do this. Now, these 4 stages make a billion times sense for me. They just do. But on your test, I'm going to show you pictures like this. So we better make sure that we are 100% comfortable with this graph, okay? So can we go ahead and do that together as a team? So let's right now, right here, this is at rest. If you notice at resting, you're at negative 70. So if I could draw this really quick, this is where sodium is on the outside and potassium's on the inside. Are you guys all okay if I stop drawing proteins because they never really move? Got it? So now let's go to the next one. So this stage right here, okay, let's go ahead and draw it in a color. Let's draw it in this purple color. This stage from right here to right here, okay, in all this purple, whoop, is called depolarization. And you know what's happening in depolarization. Sodium channels are opening. So sodium can come rushing in. Okay, now they actually start to come in until we get to negative 55. I told you, negative 55 is threshold. Once you hit negative 55, then even more sodium channels open, and it's on like Donkey Kong. Zoom! And you can see that sodium comes rushing in until I get to positive 30. Okay, that's my nerve impulse part. So now does this make sense that sodium comes rushing in? So now I've created my zing, 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 my nerve impulse. But you're not done yet. So now we got to fix the problem. So let's fix it in this blue. So from here, the top of the mountain, to the bottom of the mountain, everything in blue we're going to call repolarization. And I got to get back to negative 70 millivolts. The problem is sodium gates close, which means I cannot move sodium. So instead, now I'm moving my potassium. So now potassium gates open, and potassium starts to leave in hordes and amounts. But why it does this, the nerve temporarily cannot fire. They call that refractory. So then finally I get down to here. Let's go ahead and do it in black. This right here is called recovery. Now in recovery, the biggest thing you need to know, refractory, is ATP. I'm using ATP to pump them all back to their proper sides. That's what I desperately want you to do, just under that. And then once I get back to my proper sides, then guess what? Then I'm back to resting potential. And I can fire again and again and again and again. So if you guys understand how this works, think about a chart. If this is negative 70, negative 55 threshold, 0 is my 0 mark, and I'm going to get it up to positive 30. Okay, we always start at negative 70, but then we can have our ions come in and come out and we fluctuate. But you know what happens when I hit threshold of negative 55. That means now all the sodium gates open and sodium's begging to come in. So then I do this, woohoo! Okay, and then I shoot up really quick and I create a nerve impulse. Unfortunately, after that, I have to come down here to recover. I got to repolarize, and then I hit recovery, and I get back to resting. And then guess what happens when I get back to resting? Woohoo! You can fire again. Woohoo! You can fire again. Woohoo! You can fire again. And now you guys are starting to get the idea of how we're going to be able to read EKGs and stuff like that. It's all about ions moving. Okay? You guys understand there's so much more we could talk about with this, which is absolutely insane. So let's go ahead and talk about this really quick. This is just ideas so you guys can see the bigger picture. If I'm a nerve and I want to fire, I have potassium on the inside. My protein's always here just chilling. And then I got sodium on the outside. You know, I have to get to negative 55, which is my threshold. So that way I can jump to positive 30 to send a nerve impulse. What happens if this is all the sodium you have outside your cell and it's a really hot day and you're sweating profusely? What happens if you're sweating so much you're losing your sodium in your salt? Now please don't say your nerve's going to shut down because it will still fire, but you guys know it has to get to negative 55. So what happens if I don't have a lot of sodium? It's going to take longer to get to negative 55, which means your nerve is going to go slower. It's not going to respond to the speed you want. If you guys have not put it together yet, man, you should. We have a name for guys like these. We sell them in grocery stores all the time, and their names are electrolytes. That's what Gatorade and Allsport have made their living. They're made their living off that. So, okay, well, sorry. My butt was in the picture the whole time, but I think you guys will be okay there. Okay? So that's what you have there. That is your nerve impulse 101 on how it actually works. Okay, so here's your quiz for this one. Okay, I'm not going to do a quiz for this one because there's just so many things I could quiz on. I think the difference that might help you out is just watching a YouTube video. So do me a favor, just go ahead and cut and paste this or Google. Sorry, I should have put it as an active link, but I didn't. So do me a favor, put this into your browser. Just go ahead and watch it. It's an animation about nerve impulses, and I promise it'll make a lot more sense. Once again, you guys are absolutely amazing. Sorry this is kind of difficult content to do on your own. I wish I could answer your questions or call you and ask you questions myself, but this is just an online digital resource for you. You guys have detailed notes. You have other YouTube videos you can look at. The key on this one is it's all about ions and movement, and it's all about making sure sensory neurons travel in one direction and motor neurons travel also in a single direction. And we call this nerve impulse. So now if we go back to the very beginning, okay, the very beginning of this video, did you guys see what it was? It was this guy right here. Describe the all or none principle. Well, that's the all or none principle. What happens if you don't get to threshold? Well, then you'll never fire. It's all or nothing. And that's what an action potential is. Hey, thanks for watching these videos. I hope they help you out a lot. And go ahead and watch that other YouTube video, and I'll see you on the flip side. Thanks for watching.